So here we need to prove the following. So we'll start a problem from the left hand side. So here we have in the numerator 1 minus cosine 2 theta added to sine 2 theta and divided by 1 plus cosine 2 theta added to sine 2 theta. Now here we have a standard formula for sine 2 theta and cosine 2 theta. So sine 2 theta is equivalent to 2 times the product of sine theta times cosine theta. And cosine 2 theta has got two forms. So one of the form is going to be 1 minus 2 times sine squared theta, which means that we can rewrite this expression as 1 minus cosine 2 theta, that will be equals to 2 times sine squared theta. So this is going to be one form, and the other form will be cosine of 2 theta, that will be equals to 2 times cosine squared theta minus 1, such that rewriting the terms we get 1 plus cosine 2 theta, that will be equals to 2 times cosine squared theta. Okay, so this is going to be the next expression. Now what we'll do, in the numerator we have 1 minus cosine 2 theta. So what we can do, we can use this particular formula. We get 2 times sine squared theta added to, we have sine 2 theta, which can be also expressed as 2 times sine theta times cosine theta, whole divided by, we have 1 plus cosine 2 theta. So 1 plus cosine 2 theta will be replaced with 2 times cosine squared theta added to sine 2 theta, which will become 2 times sine theta times cosine theta. Fine. So what we'll do, we'll take 2 times sine theta as the common factor. So this will get multiplied to sine theta plus cosine theta, whole divided by 2 times cosine theta. This will get multiplied to cosine theta plus sine theta. Now we can factor out sine theta plus cosine theta from the numerator and the denominator. We can also factor out the two. We're left with the ratio sine theta divided by cosine theta, and this ratio is nothing but the tangent function, which is the expression on the right hand side. So we have successfully showed that the left hand side of the given trigonometric equation is equals to the right hand side, hence proved.